This is the demo for College Algebra Lesson 23. Suppose that the polynomial function f has zeros at -2, 1, and 2, and 3. They all have multiplicity of 1, which means the graph goes through the x-axis because 1 is odd. The graph of f is shown below. What do we know about the value of a, the leading coefficient? Well, just by looking at the graph, I know the value of a is positive because this graph rises to the right. If you look on the right side, if the graph rises to the right, the a value is positive. If it falls to the right, the a value is negative. So all I can really say for sure is that it's positive. Write the factored form of the polynomial. So we've got some unknown leading coefficient, so I'm just putting it here as an a. And then each factor can be created by doing x minus a 0. Okay, so x minus -2, that's x plus 2. X minus 1 and x minus 3. So each factor is x minus one of the zeros. What are the factors of the function f? Well, they are x plus 2, x minus 1, and x minus 3. Linear factors. Okay, so note, if x equals -2, if x plus 2 is a factor, that means f of -2 is a 0. Okay, so if x plus 2 is a factor, -2 is a 0, and the definition of a 0 means that f of -2 is 0. Okay. If x minus 1 is a factor, that means that f of 1 is 0, and if x minus 3 is a factor, that means f of 3 is 0. And vice versa. If you know f of -2 is 0, then we know x plus 2 is a factor. If you know f of 1 equals 0, you know x minus 1 is a factor. And if you know f of 3 is 0, then x minus 3 has to be a factor. So the moral of the story is, if you know a 0 of a function, then you know a factor of a function. And if you know a factor, you know a 0. Okay. So here I have it summarized here. If f of x is a polynomial, if c is a 0, so f of c equals 0, that means c is a 0, then x minus c is a factor. And if x minus c is a factor, then c is a 0. Number 2, the graph of f of x equals -6 plus 7x plus 3x squared is shown. One of the x-intercepts, or zeros, is easily identifiable from the graph. What are the coordinates of this x-intercept? So this one looks pretty clear, like it's -3. It goes right through a grid mark. This one over here doesn't go right through a tick mark, so it's not as easy to identify as this one. But I think x equals -3 is definitely an x-intercept. So given that x equals -3 is an x-intercept, or a 0, then f of x equals -6 plus 7x plus 3x squared. -3 is an x-intercept of that function. Then by the factor theorem, f of -3 equals 0, and therefore x plus 3 is a factor. So how do we find the other x-intercept? If we know one 0/factor, we can try to find the other one by using long division. Okay, just like with numbers, if you know one factor, you can divide to get the other factor. For example, I know 4 is a factor of 20, and to get the other factor, I just do 20 divided by 4, I get the 5. So now I have two factors of 20, 4, and 5. So I'm going to do the same idea, but I'm going to do division with the polynomial. So first, I'm going to arrange the powers of x of my dividend in descending order. 3x squared plus 7x minus 6 divided by x plus 3. All right, so I wrote both the divisor and the dividend in descending powers of x. Now I'm going to go through the process of long division very similarly to the way we did it with numbers. So you start out by asking yourself, x plus 3, how does it go into 3x squared? So I'm just going to look at the leading term, x. And I'm going to say, x times what would give me 3x squared? and the answer is 3x. So I'm going to put my 3x up here, and then I'm going to multiply 3x times x plus 3. So 3x times x is 3x squared, and 3x times 3 is 9x. And then I'm going to subtract. I'm going to use these parentheses to remind me I have to subtract both parts. 3x squared minus 3x squared is 0. Those go away. And then I have 7x minus 9x, which is negative 2x, and I bring down the minus 6. And then I start again. I want to know how many times does x plus 3 go into negative 2x minus 6. We start by just looking at the leading term x. What do you multiply x by to get negative 2x? And the answer is negative 2. Then we multiply negative 2 times x plus 3. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And we subtract. Negative 2x minus negative 2x is 0. Negative 6 minus negative 6 is 0. So I have found the other factor, 3x minus 2. So 3x squared plus 7x minus 6 can be factored as x plus 3 times 3x minus 2. And you can check with a quick FOIL. Multiply those out. So if you can find a 0 of a factor, maybe by a 0 of a function, of a polynomial function, maybe by looking at a graph. So we look at a graph, we find 1, 0. That means we know one factor. We can find the other factor via division. So polynomial long division is checked by multiplying the divisor with the quotient and then adding the remainder, just like with numbers, to get back to the original dividend. This process is called the division algorithm. Your dividend should always equal your divisor times your quotient plus your remainder. So in our example, we had no remainder. So our dividend was 3x squared plus 7x minus 6. And that should equal, question is, does that equal the divisor, which was x plus 3, times the quotient, which was 3x minus 2. So I'm going to multiply these together. My remainder was 0, so I'll put that there, plus 0. Okay, so when I FOIL, I have x times 3x, which is 3x squared. And then my outers, I have negative 2x. My inners, I have plus 9x. And my lasts, minus 6. So that comes out to 3x squared plus 7x minus 6, which is exactly what I wanted it to come out to. That is my dividend. So what are the coordinates of the other 0? Well, I take my other factor. So I have x plus 3 times 3x minus 2 equals 0. I set each factor equal to 0 separately. And here I get x equals negative 3. I already knew this 0 from the graph. And then the other one I can get by solving 3x minus 2 equals 0. So I add 2 to both sides, I get 3x equals 2. Divide by 3, and I get x equals 2/3. And if you go back and look at the graph, you'll see that it does look like the x-intercept is at 2/3, 0. Okay, a brief note, the help options, if you do like help me solve this or view an example in my lab for lessons 23 and 24, you may sometimes use something called synthetic division rather than the long division methods that I have just shown you. You're not responsible for learning how to use synthetic division. Please plan to continue using the long division methods covered in class. If you read the textbook and learn synthetic division and like it, you are welcome to use it. But I will not be testing you on that particular process. We're going to use long division whenever we need to divide polynomials in this class.